December 7, 1941. As Japanese bombers streak across Pearl Harbor's burning waters, American forces face a devastating reality that will reshape military thinking forever. The age of static warfare has ended. Victory now belongs to whoever can move fastest, strike hardest, and adapt quickest across impossible terrain. In the chaos of that Sunday morning, as sailors drag wounded comrades from twisted metal and oil-slicked waves, military planners already understand a harsh truth. America's entry into this global conflict demands something that doesn't yet exist: a vehicle that can carry supplies up mountain passes, haul wounded soldiers through jungle mud, mount machine guns in desert battles, and be simple enough that any mechanic in any corner of the world can keep it running. The challenge seems impossible. Traditional military vehicles excel at single purposes, but crumble under the demands of total war. Heavy trucks bog down in soft ground. Motorcycles can't carry equipment. Armored vehicles guzzle precious fuel. What American forces need is something entirely new: a mechanical Swiss Army knife that can transform to meet any battlefield demand. 6 months earlier, in a cramped engineering office in Toledo, Ohio, a team led by designer Karl Probst had been wrestling with exactly this problem. The Army's specifications read like a wish list from fantasy: a quarter-ton reconnaissance vehicle that could climb a 60% grade, ford 18-inch streams, travel 80 miles on a single tank of gas, and somehow cost less than a civilian automobile. Most engineers called it impossible. Probst saw it as the ultimate puzzle. Working 18-hour days with slide rules and determination, Probst's team began stripping away everything unnecessary. No curved body panels that required expensive dies. No chrome or luxury features. Every component had to serve multiple purposes. The hood became a work table. The windshield folded flat to reduce visibility to enemy aircraft. Even the spare tire mounted on the back doubled as extra armor for the rear passengers. The breakthrough came when they abandoned traditional automotive thinking entirely. Instead of building a car that could handle military duties, they designed a tool that happened to have 4 wheels. The result looked almost comically simple: a bare-bones rectangle on wheels with exposed mechanical components and seats that resembled park benches. But underneath that utilitarian exterior lay engineering genius. The 4-wheel drive system could send power to any wheel that had traction, letting the vehicle climb obstacles that would stop conventional cars. The lightweight body distributed weight perfectly, preventing the vehicle from sinking into soft surfaces. Most importantly, every mechanical component was designed for field maintenance using basic tools that any soldier could carry. When the first prototype rolled off the assembly line in Butler, Pennsylvania, skeptical Army officers gathered to watch what they assumed would be another failed experiment. Instead, they witnessed automotive history. The compact vehicle scrambled up steep hills that had defeated much larger machines. It splashed through streams, bounced over rocks, and carried loads that seemed impossible for its size. But the real test came when engineers began exploring just how adaptable their creation could become. Mounting points welded into the frame could accept dozens of different accessories. The flat hood provided a stable platform for equipment. The open design allowed modifications that would have required major surgery on conventional vehicles. Within months, creative minds in workshops across America were transforming the basic design into specialized tools for warfare. Engineers bolted stretchers between the seats, creating mobile ambulances that could reach wounded soldiers in terrain where larger medical vehicles couldn't venture. Machinists fabricated mounting brackets for heavy machine guns, turning peaceful transportation into mobile firepower. Communication specialists discovered the vehicle could carry radio equipment while providing a stable platform for field antennas. The production challenge seemed equally daunting. America's entry into the war created instant demand for thousands of these vehicles, but traditional manufacturing methods couldn't scale fast enough. Auto plants were already converting to produce tanks and aircraft engines. Where would the capacity come from to build an entirely new type of vehicle? The answer lay in revolutionary manufacturing techniques that treated assembly like a precisely choreographed dance. Engineers broke down construction into simple, repeatable steps that could be performed by workers with minimal training. Standardized parts meant that components built in different factories would fit together perfectly. Advanced scheduling ensured that engines, transmissions, and bodies arrived at final assembly in perfect synchronization. The Willys Overland plant in Toledo became a marvel of wartime efficiency. Raw steel entered one end of the factory, and completed vehicles rolled out the other in a continuous stream. Workers developed techniques that reduced assembly time to minutes rather than hours. Quality control inspectors learned to spot problems instantly, maintaining standards even at breakneck production speeds. This mechanical marvel that would earn the nickname Jeep, possibly from the pronunciation of GP for general purpose, or perhaps from a character in Popeye cartoons, was about to prove that sometimes the simplest solutions are the most revolutionary. Across Pacific Islands, European battlefields, and desert campaigns, this unassuming vehicle would demonstrate capabilities that its own designers had never imagined. The transformation of American military mobility was just beginning, and it would change not just how wars were fought, but how the entire world moved. But could this hastily designed vehicle actually survive the brutality of global warfare? The first test would come sooner than anyone expected. February 1942. Lieutenant Colonel Robert Hayes crouches in a muddy Philippine foxhole as Japanese artillery pounds American positions on the Bataan Peninsula. Around him, conventional military vehicles lie abandoned, their engines seized, their heavy frames trapped in monsoon-saturated earth that swallows wheels like quicksand. Yet somehow, a small olive-drab vehicle keeps appearing through the chaos, carrying ammunition to forward positions, evacuating wounded soldiers, and disappearing back into the jungle like a mechanical ghost. Hayes watches in amazement as the Jeep navigates terrain that should be impossible. Its driver, Sergeant Maria Valdez, has learned to read the jungle's moods, knowing exactly where the ground will hold and where it will give way. The vehicle's lightweight construction, initially seen as a weakness, becomes its greatest asset. Where heavier trucks sink helplessly, the Jeep's minimal ground pressure allows it to float across surfaces that would trap anything else. The secret lies in engineering choices that seemed almost reckless during peacetime testing. Traditional military vehicles were built like tanks, heavy, armored, designed to bulldoze through obstacles. The Jeep took the opposite approach. Think of it like the difference between a heavyweight boxer and a gymnast. The boxer can absorb punishment, but the gymnast can go places the boxer never could. Every component had been stripped to absolute essentials. The frame weighed just enough to provide structural integrity without adding unnecessary mass. The engine produced sufficient power without the complexity that breaks down in field conditions. Even the body panels were thin enough that a strong man could dent them with his fist, but light enough that the vehicle could climb gradients that left other machines stranded. This minimalist philosophy extended to maintenance requirements that would prove crucial in combat zones. Private Tommy Richardson, a mechanic with the 8th Army in North Africa, discovered he could perform most repairs using tools that fit in a standard field kit. The engine design borrowed heavily from civilian automotive technology, meaning replacement parts could often be improvised from captured enemy vehicles or even civilian sources. Richardson's maintenance logs reveal the Jeep's remarkable durability under impossible conditions. Desert sand that choked sophisticated engines barely affected the simple, robust power plant. Tropical humidity that corroded complex electrical systems left the basic wiring harness functioning. Arctic cold that cracked engine blocks in larger vehicles couldn't stop the lightweight engine from turning over morning after morning. But versatility meant more than just reliability. As the war expanded across multiple theaters, commanders began discovering applications that no peacetime planner had envisioned. In the North African desert, British forces under General Montgomery found that jeeps could carry enough fuel and water for extended reconnaissance missions deep behind German lines. Captain James Morrison of the Long Range Desert Group learned to navigate by stars, while his driver, Corporal Ahmed Hassan, coaxed maximum range from every drop of gasoline. Their jeep, christened Desert Fox, in grudging tribute to their German opponent, covered territories larger than entire European countries without seeing friendly forces for weeks. The vehicle's open design, initially criticized as offering no protection, actually provided tactical advantages in desert warfare. Crew members could observe in all directions simultaneously, machine guns could be mounted, and traverse through complete circles. Most importantly, the lack of armor made the Jeep nearly invisible to enemy observers, accustomed to tracking heavily armored vehicles. Morrison's unit discovered they could approach German positions in broad daylight by exploiting the Jeep's visual signature. Enemy sentries trained to spot tanks and armored cars often dismissed the small vehicle as civilian traffic or friendly reconnaissance. By the time German forces recognized the threat, the Jeep team had completed their mission and disappeared into the desert's shimmering heat. Similar adaptations emerged in Pacific Island campaigns where traditional vehicles were utterly useless. Marines landing on coral atolls found that Jeeps could traverse razor-sharp surfaces that shredded conventional tires within minutes. The vehicle's ground clearance allowed it to navigate tide pools and rocky outcroppings that would trap wheeled vehicles with lower profiles. Sergeant Carlos Mendoza, fighting with the 1st Marine Division on Guadalcanal, learned to read jungle terrain like a three-dimensional map. His Jeep became an amphibious vehicle, fording streams that reached nearly to the hood line. The simple electrical system survived repeated submersion that would have disabled more complex vehicles instantly. More remarkably, the Jeep's basic design encouraged field modifications that transformed it into dozens of specialized platforms. Combat engineers discovered they could mount everything from radio equipment to medical stretchers without compromising the vehicle's fundamental capabilities. The frame could support loads that seemed impossible for such a lightweight platform. In European forests, Jeeps carried wounded soldiers over terrain impassable to ambulances. Medics like Lieutenant Sarah O'Brien learned to convert the passenger compartment into a mobile surgical unit, performing emergency procedures while bouncing over bomb-cratered roads. The vehicle's smooth ride, achieved through careful suspension design, made the difference between life and death for soldiers with severe trauma. O'Brien's medical logs document cases where traditional ambulances would have arrived too late. The Jeep's ability to reach forward aid stations through narrow forest paths or across partially destroyed bridges meant that critical care could begin minutes rather than hours after injury. In combat medicine, those minutes often determined survival. The transformation from simple transportation to universal platform happened because engineers had built adaptability into every component. Mounting points weren't afterthoughts, they were integral design features. The electrical system could power additional equipment without modification. The frame could accept modifications without losing structural integrity. Production lines back home struggled to keep pace with demand that exceeded every prediction. Factory workers in Toledo, Detroit, and Ford's massive Willow Run facility found themselves building not just vehicles, but the backbone of Allied mobility. Assembly line worker Dorothy Mitchell watched Jeep after Jeep roll past her station, knowing that each one might carry her brother through Italian mountains or her husband across French battlefields. The human cost of this mechanical revolution was measured not just in lives saved, but in tactical possibilities that previous generations of warriors could never have imagined. Mobility had become the decisive factor in modern warfare, and the Jeep had made mobility available to every level of military organization. From generals planning strategic movements to individual soldiers carrying out reconnaissance missions, this simple vehicle had democratized the battlefield's most precious resource, the ability to be anywhere at the right time. As 1943 dawned, Jeeps were rolling off production lines every minute and 20 seconds, heading toward battles that would test every aspect of their revolutionary design. The real proof of concept was just beginning. The ultimate test of this remarkable machine would come not in American factories, but in the harshest environments Earth could offer, and the results would astound even its creators. March 1943. Captain James Macready grips the steering wheel of his Jeep as it lurches through a Tunisian sandstorm so fierce that visibility drops to mere feet. Behind him, his radio operator, Corporal Tommy Chen, desperately tries to maintain contact with advancing Allied forces while sand infiltrates every piece of equipment. Traditional vehicles have already succumbed to the desert's relentless assault, their engines choked by fine particles that slip past every seal and filter. Yet Macready's Jeep keeps running, its simple design proving nearly impossible to kill. The North African campaign became an unexpected proving ground for American ingenuity. British tank crews, initially skeptical of the Americans' lightweight vehicle, watched in growing respect as Jeeps performed tasks that seemed to defy physics. Where their own vehicles required extensive maintenance after every desert patrol, these unassuming machines simply kept functioning. The secret lay not in complexity, but in elegant simplicity. Fewer parts meant fewer failure points, and accessible components meant repairs could happen anywhere. Desert warfare revealed the Jeep's first truly revolutionary capability, its ability to extend the reach of military operations far beyond traditional supply lines. Reconnaissance teams discovered they could venture hundreds of miles into enemy territory, carrying enough fuel and supplies to sustain missions that would have been impossible with heavier vehicles. The Jeep's modest fuel consumption, roughly twice as efficient as comparable military vehicles, transformed tactical planning across entire theater commands. Staff Sergeant Rosa Martinez learned to read the desert like a navigation chart during her missions, supplying isolated British observation posts along the Kasserine Pass. Her Jeep, loaded with radio batteries and medical supplies, became a lifeline for forces operating in terrain so remote that traditional logistics networks couldn't reach them. Martinez developed techniques that would later become standard doctrine, using the vehicle's low profile to avoid detection, its quiet engine to approach enemy positions unheard, and its nimble handling to escape pursuit across broken ground. The desert trials revealed something unprecedented in military history: a single vehicle platform that could adapt to mission requirements rather than forcing missions to adapt to vehicle limitations. Intelligence officers discovered they could mount cameras for aerial reconnaissance when the Jeep was fitted with small aircraft observation equipment. Medical personnel found that stretcher brackets transformed it into an ambulance capable of reaching wounded soldiers in locations no conventional medical vehicle could access. Communication specialists realized the Jeep's electrical system could power radio equipment far more sophisticated than originally intended. But Africa was only the beginning. As Allied forces prepared for the invasion of Sicily, planners faced a different challenge entirely: mountainous terrain that had stopped armies for centuries. July 1943, Lieutenant Sarah Kowalski navigates her Jeep up a Sicilian mountain path, so steep that her passenger, war correspondent Michael O'Brien, closes his eyes rather than look at the precipitous drop beside them. The trail, carved centuries ago for donkeys and foot traffic, seems impossibly narrow for any motorized vehicle. Yet Kowalski has learned to exploit her Jeep's unique characteristics. Its short wheelbase allows sharp turns that longer vehicles cannot make, while its lightweight construction prevents the soft shoulders from collapsing under excessive weight. The Mediterranean campaign transformed military thinking about terrain accessibility. Mountains that had traditionally channeled armies into predictable valleys now became highways for forces equipped with vehicles capable of goat-like agility. German commanders, accustomed to controlling movement by blocking conventional routes, found themselves facing attacks from directions they had considered impossible to traverse. Kowalski's unit, the 127th Mountain Supply Company, pioneered techniques that redefined mountain warfare logistics. They discovered that Jeeps could climb grades approaching 45 degrees when properly loaded and driven with skill. More importantly, they could descend equally steep slopes under control, using their excellent brakes and low center of gravity to maintain stability where other vehicles would tumble into valleys below. The Jeep's versatility reached almost absurd extremes during the Italian campaign. Engineers welded railroad wheels onto axles, creating hybrid vehicles that could travel both roads and railway lines. Artillerymen mounted small cannons on reinforced frames, creating mobile fire support that could appear anywhere the infantry advanced. Even more remarkably, maintenance personnel developed field modifications that could be completed in hours rather than weeks, adapting individual vehicles to specific mission requirements using salvaged materials and battlefield ingenuity. Private First Class David Kim witnessed this adaptability firsthand while serving with the 442nd Infantry Regiment during their advance through the Italian Apennines. His unit's Jeep, originally designed for reconnaissance, had been successively modified to serve as an ambulance, a supply transport, a mobile command post, and finally a makeshift artillery spotter equipped with powerful optics salvaged from a damaged tank. Each transformation required only basic tools and demonstrated the fundamental wisdom of the original design, simplicity that invited innovation rather than preventing it. Meanwhile, across the Pacific, Jeeps faced challenges that their designers had never contemplated. Jungle warfare in conditions so hostile that metal itself seemed to dissolve under the assault of humidity, insects, and corrosive vegetation. September 1943. Sergeant Major Elena Vasquez wades through knee-deep swamp water on Bougainville Island, guiding her waterproof Jeep through terrain that exists somewhere between land and sea. Around her, the jungle pulsates with sounds that speak of hidden dangers, not just from Japanese forces, but from an environment so hostile that survival requires constant vigilance. Her vehicle, sealed against water intrusion and equipped with specialized air intake systems, represents months of hard-learned lessons about jungle warfare. Pacific operations revealed the Jeep's most remarkable characteristic: its ability to function in conditions that destroyed more sophisticated equipment. The humid, salt-laden atmosphere that corroded complex machinery seemed to have minimal impact on the Jeep's straightforward mechanical systems. Its air-cooled engine avoided the overheating problems that plagued liquid-cooled vehicles in tropical conditions, while its simple electrical system resisted the moisture-related failures that left other vehicles stranded. Vasquez had learned to maintain her Jeep using techniques that would have seemed impossible in peacetime. Spare parts came from disabled vehicles, improvised repairs used materials never intended for mechanical applications, and preventive maintenance happened under conditions where simply keeping equipment dry required constant effort. Yet her Jeep continued performing reliably, crossing rivers that would have stopped heavier vehicles and navigating jungle trails that seemed designed for creatures rather than machines. The Pacific Theater demonstrated the Jeep's psychological impact as powerfully as its mechanical capabilities. Japanese intelligence reports from captured documents revealed growing concern about American mobility advantages. Enemy commanders, accustomed to controlling island battles by dominating key terrain features, found themselves facing opponents who could appear anywhere, strike quickly, and disappear into jungle that had previously provided perfect defensive positions. By late 1943, Jeep production had achieved what manufacturing experts had declared impossible: consistent quality output at unprecedented speed. Factory workers in Toledo had refined their techniques to the point where complex assembly operations flowed like choreographed performances. Each vehicle that rolled off the production line carried within its simple frame the accumulated wisdom of thousands of field modifications, combat experiences, and engineering improvements. The transformation was complete. What had begun as an emergency procurement for a specialized military vehicle had evolved into something far more significant: a revolution in how modern societies thought about transportation, logistics, and mechanical reliability. The Jeep had proven that the most sophisticated solution to complex problems often lay not in adding complexity, but in achieving perfect simplicity. As Allied forces prepared for the massive operations that would determine the war's outcome, they carried with them a weapon that no enemy had anticipated: the ability to be everywhere at once, supplied by vehicles that simply refused to quit. The war's end would reveal that this humble vehicle had accomplished something unprecedented in military history. It had fundamentally altered humanity's relationship with mobility itself. August 1945. Dr. Elizabeth Hartwell stands in the ruins of what was once a German research facility near Munich, watching American engineers load scientific equipment into a convoy of Jeeps. Around her, the infrastructure of the Third Reich lies in twisted metal and broken concrete. But these small American vehicles navigate the devastation as if the obstacles barely exist. What strikes Hartwell most profoundly isn't just the Jeep's mechanical capability, but how it has democratized transportation in ways that will reshape the post-war world. The numbers told only part of the story. Over 600,000 Jeeps had rolled off American assembly lines during the conflict, but their true impact extended far beyond battlefield logistics. In remote Pacific islands, Jeeps had carried medical supplies to indigenous populations for the first time in history. Across war-torn Europe, they had become the backbone of humanitarian relief efforts, reaching villages that had been isolated for years. In Burma and China, they had connected communities separated by geography that had seemed insurmountable. But the real revolution was just beginning. Captain William Rodriguez, recently returned from the European theater, purchased his first civilian Jeep in September 1945 from surplus military stock. What he discovered changed his entire conception of where humans could live and work. His ranch in Colorado's high country, previously accessible only by horseback during summer months, suddenly became a year-round operation. The Jeep's ability to navigate mountain passes in conditions that defeated conventional vehicles opened up vast regions of the American West to development, tourism, and settlement. This pattern repeated across the globe. In Australia, Jeeps enabled ranchers to manage cattle across territories the size of European countries. Brazilian coffee farmers used them to reach plantations in mountainous regions that had required days of travel on foot. Norwegian fishermen employed them to access remote coastal areas where traditional trucks simply couldn't function. The vehicle that had been designed for warfare was quietly transforming peacetime life in ways its creators never imagined. The engineering lessons learned during wartime production revolutionized American manufacturing philosophy. The techniques developed to produce Jeeps every 80 seconds during peak wartime output became templates for mass production across entire industries. Automotive executives like Henry Ford II studied Jeep assembly methods, incorporating their efficiency principles into civilian car production. The result was a post-war manufacturing boom that made complex mechanical devices affordable for ordinary families. More significantly, the Jeep had proven that truly universal design was possible. Unlike specialized vehicles that excelled in narrow circumstances, this single machine could adapt to virtually any transportation challenge. It could pull agricultural equipment in Kansas wheat fields, navigate logging roads in Oregon forests, serve as emergency vehicles in urban environments, and provide reliable transportation across terrain that had previously been accessible only to hikers and pack animals. The 40 different military roles that Jeeps had performed during the war expanded into hundreds of civilian applications. Police departments discovered they could patrol areas previously beyond their reach. Fire departments used them to fight wildfires in mountainous terrain. Construction. Companies employed them at building sites where larger vehicles couldn't maneuver. Rural doctors relied on them to reach patients during emergencies when weather made normal transportation impossible. Perhaps most importantly, the Jeep had demonstrated that mechanical reliability didn't require complexity. Throughout the war, field mechanics with minimal training had kept these vehicles operational using basic tools and common sense. This philosophy of maintainable simplicity influenced everything from farm equipment to household appliances in the post-war era. American engineers had learned that the most sophisticated technology was often the kind that ordinary people could understand, repair, and adapt to their specific needs. The vehicle's influence on global development became apparent as surplus Jeeps spread throughout the world. In newly independent nations across Africa and Asia, they became essential tools for building infrastructure in challenging terrain. Government officials could reach remote communities to establish schools and medical clinics. Engineers could survey routes for roads and power lines across landscapes that had previously been largely inaccessible. The Jeep essentially accelerated the development process by decades in regions where geography had been a primary obstacle to progress. By the 1950s, the original military Jeep had spawned an entire category of vehicles designed around the same principles: simplicity, versatility, and uncompromising reliability. Civilian versions retained the military model's essential characteristics while adding comfort features for everyday use. The concept proved so successful that virtually every major automotive manufacturer eventually developed their own interpretation of the utility vehicle. The cultural impact proved equally profound. The Jeep became a symbol of American ingenuity and democratic ideals, a machine that could take anyone anywhere, regardless of social status or economic background. Unlike luxury vehicles that emphasized exclusivity, the Jeep represented accessibility and self-reliance. It embodied the American belief that technology should serve human freedom rather than restrict it. Today's world would be unrecognizable without the transportation revolution that began with wartime Jeep production. Modern sport utility vehicles, delivery systems for remote areas, emergency response capabilities, and recreational access to wilderness regions all trace their origins to the engineering principles established during those desperate months of 1940 and 1941. The global economy depends on transportation networks that reach into previously inaccessible regions, capabilities that the Jeep first demonstrated were possible. The vehicle that had been born from military necessity had inadvertently solved one of humanity's most persistent challenges: how to move people and goods efficiently across the Earth's most difficult terrain. In doing so, it had expanded human possibilities in ways that continue to shape how we live, work, and explore our world. The simple machine that rolled off Toledo assembly lines every 80 seconds had delivered something far more valuable than military victory. It had delivered freedom itself,